Hello everyone, my name is David Townsend. I'm a partner sales engineer here at Juniper Networks, and it's my absolute pleasure to take you through this fourth and final installment of Apstra, which is Juniper Networks multi-vendor intent-based networking solution for data center requirements. But first and foremost, I'd like to thank our partner Kubus for hosting all of these great sessions with myself to show Mist and to show Apstra and all the previous sessions that we've ran. But if you do have any questions following this recording, please do email sales@kubus.com and they will be more than happy to go through any questions or comments, etc., that you may have. So without further ado, let's actually begin. So as I said, this is the last installment, and this is going to be focusing on the day 2+ operations of data center networks. When we talk about day 2, we're talking about really the operational side of data centers, when the equipment is up and running, and hopefully that traffic is running within the expectations of the operator and the business itself. But when we talk about data centers, there is a growing demand for more reliability and really simplifying the data centers operations. And if you look at it from a challenge point of view, there's the great resignation. There's, of course, supply chain restrictions and cyber warfare. And these aren't just buzzwords. These are real data center challenges that real companies like yours are no doubt experiencing every day. And if we look at Nord Stream, for example, they saw their IT team drop significantly by a certain percentage during the pandemic. And they couldn't hire their way out of the problem, and they had to turn to automation software. And because they did not want to be reliant on a single hardware vendor, it had to provide insight across any and all hardware platforms. Another one, such as Chevron, wanted to hire an army, basically, of software developers to work on Ansible, but they really found it was impossible to hire and keep such real specializations and talent, and ultimately just really gave up on their mission. And finally, T-Systems, they recently made their decision to consolidate from 45 data centers down to 11, whilst continuing to handle the company's performance, availability, and scalability requirements. And by the way, these are all Juniper customers, all Juniper users of the Apstra solution. So when we talk about Apstra, we're talking about automation, we're talking about multi-vendor, and we're talking about a single source of truth. And this is essentially what we know our customers who are using Apstra really need: the automation to give them that peace of mind to simplifying their operations and deployment of data center and complex technologies, supporting multi-vendors, and having that single source of truth based on their intent. And oftentimes, to address those pain points, customers require speed, efficiency, insight, and security. However, the fundamental problem is reliability, and reliability is, excuse the cliche, but is really the backbone of success in data centers. And without reliability, even if you have speed, efficiency, and insights, and of course security, those results will not be sustainable. And how do you build a reliable data center? Well, it's with these 4 pillars: design, build, deploy, and operate. Now, the first session, the second session technically that I recorded, was where we had the day 0 operations of designing and building your data center, your clause 3, clause 5, with or without DCI, etc. That was really the design phase, building your intent, building your network. The next video installment was the day 1 operations, where we covered deploying your intent onto the network itself. And here during this session, we're talking about operating the day 2+ operations. But to build that reliable network, at Juniper, we've got Apstra, the intent-based networking. We have the only multi-vendor solution for data center environments. So it doesn't matter if it be Juniper, Arista, Cisco, Dell. We can work, obviously with Juniper, we can work with all these different vendors, regardless of the underlying hardware. Well, obviously within reason that they have to be the data center equipment. When we look at Cisco, that would obviously be the Cisco Nexus switches. And then, of course, we've got Ansible, VMware, NSXT, and Sonic on top of it. And really having these 4 pillars allows us to have that repeatable and reliable operations, essentially having a building block of different frames, like pieces of Lego, which you can piece together to make that end solution itself. And all these pillars are possible with intent-based networking. And intent-based networking is a holistic closed-loop validation architecture. What it does is it continuously analyzes data center behavior in real time against defined policies and enables an efficient and reliable method to changes in the network. And the benefits include managing change reliably, doing more with less, delivering on your business intent, the power of configure, and then operating, leveraging the analytics to derive meaningful knowledge from the network itself. So it's a very powerful, very automated and flexible solution that's Apstra that uses intent-based network. And an intent is basically what you want to achieve out of the network. The intent is your business, it's your operational requirements. From a technical point of view, it's how the network should be running, who's connected to what speeds, who's talking to who, or who's peering with who, so on and so forth. That, all in all, is your single source of truth. That is your intent. And we actually use Apstra to poll this single source of truth, so we can look for any deviations, look for any changes, and real time report back to the user on those changes which have deviated away from that single source of truth, i.e. your intent. And what we show, and I'll be showing on the demo, is this GraphQL. And it doesn't look like much here, but because each of the elements, the nodes, have a relationship to each other, like a transceiver has a relationship to an interface, and it has a relationship to a physical link, and on the other side, that physical link will be another transceiver, another interface. They have relationships with each other. And so if a transceiver is unplugged, or if it's operating too hot, or it's becoming faulty, which deviates not the configuration, but the performance away from the intent, then the single source of truth will be able to see that and again report back to the administrator, to the operator. And so with the Apstra capabilities, as I showed, we could design, build and deploy the data center before even that network hardware is in place, allowing you to have your Apstra solution up and ready for when the hardware is actually installed. And you can manage multiple sites. It's not just a one data center, depending on the license, of course. You can have multiple what we call blueprints or more, and it's using ZTP, yes, so zero touch provisioning. And then using operations for expanding the network, opening up new ports, changing security policies, routing policies, configuration policies, upgrading the network devices as well. So I'm going to show something called drain mode, where we can drain traffic away from specific switches, whether it be Juniper, Cisco, Arista, it doesn't matter. And within the automation assurance, the ability to identify root causes of an actual anomaly, as we call it, to configure intent-based analytic probes, where you probe the network to see what the throughput is like and how links are operating, what's the ESI like, as an imbalance between ESI links, so on and so forth. And then we've got this multi-vendor flexibility, and this should not be taken lightly, because there are different switching ecosystems. And with Apstra, customers have the flexibility to support multiple vendors' platforms. And hardware can vary, but Apstra provides one method, one solution, one management platform to manage and deploy hardware. And it really does not matter what that hardware is. And then we've got the intent time-voyager. So, for example, if you make a configuration change on your network, or you deploy a new piece of software onto a switch, regardless of the vendor, and things aren't operating as the way you'd expect, the intent-based time-voyager allows you to, as such, roll back in time And what it does is it takes a snapshot of the known good configurations, and then within a few clicks, you can actually roll back the entire network from, as it's shown here, from Tuesday, where it's a broken network, back to Monday, where it was actually a working network, all within a few clicks of a button. And it's given a single point of view of the entire network health. So this is the dashboard, and we can see, are there any anomalies for all the probes? You can see there's one anomaly, but that's then linking, if you look further to the right, to generic systems. So this is actually talking about the generic system servers, whether it be bare metal server or firewall, doesn't matter in this context, but we can see that there's 2 anomalies for BGP, which is all in all alerting that there's 1 anomaly for the probe. So you're going to get many different tables, whether it be peering, verification, liveness. There's many different tables for anomaly detection within a single pane of glass. And then we are also doing continuous validation. So as you can see here, this would be a spine, this could be a leaf, super spine, but we're seeing, are there any anomalies in the BGP, the physical cabling, in the configuration, in the interface, in the multi-chassis lag, probes, route table. And we can also see what's the BGP state, who you're peering with, the ASN numbers, host names, and the to the right where the expected state is. So based on the intent, it should be up for both the spine to leaf rows, and the actual state. And obviously, if there's a deviation where the expected is up but the actual is down, that's obviously going to be highlighted and reported to the operator. And it's not just for BGP tables; it's for route tables, configuration tables, and a lot more. But from an overview point of view, for day 2 operations, we have the ability, even though this is an up and live as such running network, where you've got the hardware connected and hopefully everything's passing traffic, you can still expand those links, those leaves, those racks. You can add in new top of rack switches. You can enable new ports. You can disable currently running ports. You can roll back or roll forward using the time-voyager. And once you've made those changes, which you can see here, that is then reported and installed in that single source of truth, that GraphQL database. And that's your intent, don't forget. So the single source of truth is staying up to date with your intent, i.e. your network model, as it changes through time. And then that configuration is then deployed onto using ZTP and a number of API calls, depending on the hardware vendor. Those APIs will change, but typically it's netconf SSH. But those configurations will then be deployed to those hardware vendors themselves and seamlessly updated in terms of configuration remotely. And then that's the configuration part. But once these devices are obviously connected and they're running that configuration, they're then reporting all the telemetry back up to that single source of truth, that GraphQL database. Again, that's your intent. And from that, we're able to then derive meaningful and insightful analytics onto heat maps, onto specific interfaces themselves, onto the dashboard, as you just saw. Is there any anomalies for BGP peering, for route tables? Also to do anomaly detection, creating intent-based probes to see if there's a lag imbalance and an ESI imbalance, over CPU utilization, whatever it may be. And also to see, has some engineer, obviously you're not going to get the name of what engineer, but as an engineer unplugged a port on a leaf and he or she's connected it back into the wrong port, i.e. there's a mismatch there, there's a misconfiguration. There should be port 1 should be connected to spine 1, but now it's connected to leaf, to port 2. That would be detected as an anomaly based on the analytics using that single source of truth. So as you can see, this is a lot. It is very a very powerful solution for day 2 operations. And this is supported from a Juniper point of view. We have a range of different data center solutions, different data center products from our QFX Firecase. That's typically the 5100 family, and there's a mixture of different switches within that. We also have our ACX and MX routers for example, your DCI connectivity. And if you want very powerful and very ramped up, and as you can see here, multi-blade chassis, and then we have the QFX 10K or PTX family as well. So we have a very wide range of products here for our data center. But the Apstra solution is that management solution that sits on top of this, whether it be Juniper, Cisco, Arista, etc., manages that solution, those hardware devices remotely. So enough of me talking and going through slides. Let's actually go onto a demonstration to talk about all the use cases here. So let me just bring up the page. Here we go. So this is the demo, and it is different from the previous videos I've done, and that's purely because my bare metal server has been going through an upgrade. It's running EVE-NG, and I haven't fully got EVE-NG up and running yet. But it doesn't matter, it's still day 2 operations. But here I'm just using a specific Juniper Cloud Labs. So here's my blueprint, and I'll show you the model of what's deployed in just a few minutes. But here you can see, yeah, as it is my blueprint, but we can see really, you know, everything's green, everything's looking fine. You know, it's deployed, there's no service anomalies, there's no root causes, everything is looking pretty good. But if I click on the blueprint itself, I can then go into that dashboard based on my blueprint. And if you're wondering what a blueprint is, without reverting back to the previous videos, a blueprint is basically that data center instance. It's all those spines, leaves, the access switches, the topology you intend for a single data center network. So basically, a blueprint is a deployed intent on your data center. And if you want to manage 2 or 3 or 4 plus data center environments, then you need 2 or 3 or 4 plus blueprints. And depending on the license, we have different licenses. There's only 3 of them where you can have 1 blueprint, 2 blueprints, or 3 plus blueprints, depending on what you actually need. But what we can see from a dashboard point of view, it looks very healthy, doesn't it? Everything's great. You know, the IP fabric, the underlay, there's no anomalies. For the generic system, so these are the generic servers which are connecting, everything's looking great. Root tables, deployment status, leaf peering, liveness, probes which are running, everything is looking great. And if we go down, we can see there's no lag imbalances, there's no fabric ECMP imbalances, there's no ESI imbalances, really there's no anomalies. And this is the ideal scenario, and I promise you this is not going to stay the way for long. But if I go into analytics, here's where we can create your customized dashboards. Now, obviously, that's not unique. Everyone has dashboards. Everyone has widgets. But here, just to show, is the ability to create your own dashboard with your customized widgets. So you can see here, this is just one I've created. You know, device traffic hotspots. It's just been created just over an hour ago by the administrator myself. And here I can see, you know, is there any traffic hotspots going between the actual links themselves, you know, transmit, receive, leaf 1, leaf 2, spine 1, etc. So they're not really transmitting and receiving. Like, this is a pretty empty network right now. There's no real traffic going over it. Drain validation. So drain validation is when you drain traffic away from a leaf, a spine, very smoothly, shall we say, very elegantly, by basically using Apstra to deploy an ACL, which will signal out to, and it's deployed onto that particular device, and it will signal out to other nodes which are connected to it to stop sending traffic to it, and it slowly drains the traffic away. So then you could do that hardware change or software upgrade, whatever it is you need to do from a network maintenance perspective. But here you can see there's a lot, and of course you could create your own dashboards. You can go into widgets, create your own widgets, but there are some out-of-the-box pre-configured widgets for you. As I said, you can mention your own, but whilst these might look pretty straightforward, I can assure you they're actually quite complex. So the Ethernet segment identifier imbalance for multi-homed connection, so a server that's, or firewall, whatever it may be, that's connected multi-homed to a leaf device, typically. If I actually go onto the properties, we can actually see, actually it's a lot more complex to get to that imbalance count. So first we take the ESI interface traffic, which feeds into the ESI interface traffic average, which then feeds into the traffic imbalance, to standard deviation percentage on the ESI, to this, to that. So these are very sophisticated, very complex, but very meaningful widgets which allow you to ultimately determine and understand, yes, how's the performance, but in this particular case, what is the ESI imbalance between one link and another link. And let's carry on. So what I'm going to do in the background is just do something. So you're going to see what that is in just a few seconds time. But if I go back to analytics, so if I go into anomalies, we can see that there's no anomalies. That's great. And on widgets, as I just showed, you can create your own widgets. Probes is where you can create your own probes as well. So here is where you're going to probe the network to check for device traffic, to test for ESI imbalances, to test for ECMP imbalance on the fabric itself. So if I actually go, let's do a different one into ECMP imbalance itself, we can then see, right, well, we can actually see that there's, right now for leaf 3, which is using this particular port, it's using not many packets per second. It's obviously increasing, and leaf 2, but these are okay values, aren't they? But if it was an imbalance and causing imperfection, shall we say, that would be reported on the dashboard itself, which is a good time because pointing at this, we can now see that something's wrong here, obviously indicated by the red explanation mark. So what can we see? We can see that there are 2 cabling anomalies, which have just then changed into 1 BGP anomaly and 2 interface anomalies, and 6 anomalies for the route table. Okay, so that's a lot. So we've got IP fabric, the underlying anomalies, which is then impacting the route verification and route table itself. And if I scroll down right at the bottom, you can actually see from a dashpoint point of view what nodes are seeing these anomalies. So we could see spine 1 is seeing 1 BGP anomaly, 1 cabling anomaly, 1 config anomaly, 2 interface anomalies, and 2 route anomalies itself. So really the big impactor here is spine 1 with 7 anomalies in total, whereas the others only have 1 each. So it's easy to see that spine 1 is that common denominator itself. But if I go into active, here I can actually see all the active running configuration, but also show you, spine 1, spine 2, we've got 2 top of rack switches in rack 1, 1 in rack 2, but specifically we could see, well, spine 1 is seeing issues, leaf 1, leaf 2, leaf 3 are seeing issues. But as I said, that common denominator was spine 1. So if I click on spine 1, I can then see, hang on, there's a violating intent here. This interface should be up, but it's obviously down. It's a violating intent. Port 0 and port 1 are great, they're okay, but port 2 is down. That's, is that an engineer who's unplugged it, or is that simply a configuration? Now, what we can see on the right-hand side is there's 7 in total, so 1 plus 2 plus 1 plus 1 plus 2, you get 7. But we can see there's configuration anomalies. So let's check configuration first. So if I go into configuration, we can then, Apstra has then fetched all of the configuration of the configuration, what is intended based on your single source of truth, on the single source of truth, i.e. your intent, and what's actually running on the configuration itself. And what we can see, I think I just went by it, is here. So here, the actual was supposed to be for port 002, was supposed to be up and running, was not supposed to be disabled. But the actual configuration here for the same port has now been disabled. So someone has disabled this interface on this switch, and because it's managed by Apstra, the telemetry is reported up into the single source of truth, and it's seeing that there's a deviation from the expected to the actual, and it's reported back to the end user that. And we can scroll further down. We can then see, are there any routing mismatches? Are there any policy mismatches? But I can assure you, everything is that's not going to be the case. But what we can absolutely see is that there is a disable configuration on that particular port itself. Now, what do you do then? Well, you can either accept the changes and say, yeah, that's fine. You know, what the engineer has done, that's correct. Or you could say, I don't know what David Townsend is doing. He shouldn't have done that. I'm going to apply the full configuration that I've got saved based on my intent, i.e. port 2 is not disabled, and I'm going to override that. So once I click apply for configuration, I'm going to confirm that. And then it's going to apply that configuration and basically override what David Townsend, that engineer, has done on that particular switch itself. So now everything is running fine. And if I go back to the blueprint, what you'll see over time, BGP obviously does take 90 seconds, if I remember correctly, but these will all normalize over time. You can actually see that, you know, the anomalies are going to slowly decrease. Again, that's going to take time because BGP does take time. But let's go onto active, shall we? Back to active. Now, onto stage. Now, I did mention the drain mode itself. So how do you go onto, how do you drain a piece of equipment? Well, just say, for example, you want to do a piece of software upgrade on Leaf 1. So let's click Leaf 1, and we can see it's currently in deployed mode. We can see all the interfaces which are running. And if I go into deploy mode here, I can then see, well, deploy, ready, drain, or undeploy. I maybe want to completely rip it out and put a new piece of hardware in. But if I select drain and save, it's then going to drain slowly all of the traffic going from the spines to Leaf 1, from the generic servers to Leaf 1, etc. Onto the external router is going to be drained away from here. What I do have to do is go to uncommitted and actually then just commit that configuration and say drain Leaf 1, commit that, and then that will actually apply that configuration change onto that device. Now, just say, for example, you've done that software upgrade and the software, it has bugs or it's not operating as you would hope it actually is. Let me go into dashboard. So these should be clearing about now, but that's fine because I've just noticed I've still got the thing running in the background, but slowly they're actually decreasing. It's just taken longer than I thought. But let's say your software isn't as expected. So let's, everything's looking great now. Actually, so that was about 90 seconds. But let's say your software is not running as you expected. time-voyager allows you to revert back to a specific moment in time where, as the slides showed, there was a working network. I'm just wondering why this is not a live network, so it's not allowing me to refer back to those changes. I've got to go into time-voyager. That's always a good start. Human error remains the #1 fault on any network, but on time-voyager here, so here's actually where I just deployed drain Leaf 1. But say, for example, you wanted to revert back to that software version that was installed, not just on Leaf 1, but throughout the entire network and all the configurations therein. So, right now, Leaf 1 is drained with a specific software, installed on top of it. But say you want to revert back, what I'll do is jump back to this revision, push roll back, done, and that's it. I'm then going to be, Apstra is then going to move the entire network. It's done that snapshot. It's then going to revert back to, once I commit it, Leaf 1 deploy. It's then going to roll back the entire network to that one instance in time. And yeah, we can see that there's current active because it's obviously just deploying it all, and this will normalize over time. But whilst it's doing that, I also want to show you the GraphQL database. So if I go into staged, we've got this Graph Explorer at the top here. And what we can see is nothing right now, but if I just show the full blueprint, and then here you go, boom. Now that doesn't look, what does that mean? That is your single source of truth. That is your business, your operational intent. That is what you want to achieve out of the network. And Apstra has built that relationship between all those different nodes. And you can see all the different nodes here, from fabric addressing to links to logical devices to metadata. It's the entire relationship between it all. And that's why when the telemetry comes back up from the devices, or you deploy a configuration change from Apstra, the single source of truth is queried continuously. And if there's a deviation, if there's a change, it will either apply that change if it's a configuration change down to those network devices, or if it's telemetry deviation, it will report that deviation back to that operator itself. But let me just let's unshow it all. And what I will do is I'm just going to enable a few. So let's do link, logical device, and interface, just interface map. So here we can see, just I've simplified it a bit, is the relationship between all the different nodes. And I'm just moving them away from each other. So just here, we can see show on hover. So this is interface with that device. It's interface type Ethernet, port 3 on leaf 2, and it's got a relationship to this link, this ID, EVPN, ESI, 10 gig, and on the other side is this interface switch to server 1 using this interface. So if one of these links goes down, or the interface is disconnected, that relationship is broken, which then reports back to the administrator that a single source of truth has seen a change, it's seen an anomaly, and that will also be reported on the dashboard itself. Now, this is very powerful because then what you can do is run specific queries in here to check for interface name, interface temperature of transceivers, CPU. Obviously, this is a lot more technical, but you can run a huge range of different queries based on the single source of truth to actually see and monitor and detect and investigate all the different variances of those queries that you can enter in here. If I come back to here, we can see, yeah, everything is great now. If I go back to stage, we can see leaf 1 is deployed. It wasn't drained before, but using the time-voyager, it rolled it back successfully. And if I go into the active and go into spine 1 and links, we can see all the links, so we can see which ones are currently not assigned. If we go into pods, we can see this is all part of pod 1. We can also see our virtual routing policies, virtual networks routing zones. We can see the policies themselves for interface routing, so there's nothing really configured here. But if I go back to staged, let's go racks. Let's actually go links. Let's go to this link itself. And what you would be able to do is change link speed. So as I said, you can do configuration changes. So if we do change link speeds, you could say, well, I want to change these interfaces here from 10 gig to 1 gig, just for example, push update. And what that would then do, I've done an error. Okay, so that particular device doesn't support 1 gig on those interfaces, but that's great because Apstra's just said, well, actually that interface doesn't support 1 gig, they're only 10 gig. But what you would be able to do is then actually change those interfaces from 10 gig to 1 gig, 100 gig, whatever it may be, obviously if the hardware itself does support it. So looking at time, let me go back to the slides. So that was a very quick demo on the day 2 operations of Apstra itself. And here's just a few quotes from some of our users, some of our customers who are using Apstra. And I've highlighted and underlined the parts of, for me, that I want to highlight to you. You know, Apstra provides us with a level of management and flexibility we didn't have before. And further down, we had a fully operational network from the moment we plugged in the switches. Again, Apstra is providing a reliable, repeatable way of automating and managing data center networks, and you can have that network designed and built before the hardware is even installed in your data center environment. Darko from Advania. When compared to other solutions, Apstra's level of automation, provisioning, and visibility offers far more capability. It helped build and maintain a reliable network. Again, that word, reliability, by ensuring that the operational state of the network is always running as intended, because we're using intent-based networking. And Bloomberg, very short here, Apstra system gives us a single view into the entire media production, regardless of devices, switches, operating systems, or vendors. Because we're multi-vendor, it's the only multi-vendor solution out there. No one else can do what Apstra can do, and because of that, it's been recognised. There's been Forrester reports. It's cool vendor in enterprise networking. Really, we should be in our own category of a magic quadrant for intent-based networking systems, but it's been proven to reduce network infrastructure delivery times by 50 to 90%. And it is a very efficient way of reducing all the operational lead times, whether it be day 0, day 1, day 2 operations, very significantly, which has been highlighted in a recent Forrester report itself. And to finally finish off, Juniper Networks, we are a leader in the Magic Quadrant for data center and cloud networking. Apstra is a cool vendor in enterprise networking. And for Gartner's intent-based networking systems, it can reduce network infrastructure, as I said, by 50 to 90%. So thank you for your time. I've gone a little bit over time, but that's always to be expected sometimes. But thank you for your time. I hope you found that useful and insightful. And again, thank you to our partner Kubus for hosting and running all these different great sessions. Thank you so much. But if you do have any questions, please contact or email sales@kubus.com. And again, they'll be happy to take any questions you may have. Thanks again, and I look forward to hopefully seeing or speaking to you soon. Thank you very much. Goodbye.